Hey everybody, welcome back. Today we are continuing chapter 2 and we're talking about what to do with significant figures when we have calculations that involve sig figs or measurements. It's really important when you're doing calculations that involve inexact numbers, measurements, things that have sig figs, that you keep track of them. You don't want your final answer to have more precision than the measurements it came from. And so you follow these rules that I'm going to go through to make sure that you keep track of your sig figs as you do multiplication, division, addition, and subtraction, so that at the end of your series of calculations, you report your final answer with the correct number of sig figs. Okay, so keep calm and follow the rules. There's going to be rules for rounding, multiplication and division, and addition and subtraction that we're going to go through. We'll start off with rounding. The first thing you want to do is you need to decide how many sig figs the final answer should have. We're going to talk about how to figure that out with the other operations, but once you know how many sig figs you want your final answer to have, to round to that number of sig figs, you count that number of digits starting from the left. If the number immediately to the right of your last sig fig is less than 5, it gets dropped and the value of the last sig fig remains the same. If the number immediately to the right of the last sig fig, last digit, is greater or equal to 5, then you round that last sig fig up by 1. So I know that was a lot of explaining for something that you probably already know how to do from math, but let's do some review. So if we wanted to round 5,638.9 to 4 sig figs, we start counting at the first sig fig most to the left. That's sig fig number 1. And we want to count out 4 sig figs. So here's 1, 2, 3, 4. So we want this to be our last sig fig. And so we have to determine if we need to round this 8 up to a 9 or if it should stay an 8. And so to do that, we look to the digit to the right of it. This is our last sig fig. Look to the right. It's greater than 5. Greater than or equal to 5. So we're going to round the 8 up to a 9. There. Round up. So we end up getting 5,639 when we round that 8 to a 9. And we have 4 sig figs as was requested. Okay, if we have the same number and this time we want to round it to 2 sig figs, we count 2 numbers over from the left, 1, 2. So this is going to be our last sig fig. So once you've identified your last sig fig, you look to the right. And in this case, it's less than 5. And so we're going to round by leaving the last sig fig as is. So we get 5, and then the 6 stays a 6 because the number immediately to the left of it was less than 5. So 5, 6, and then we fill in those other spots with zeros. You want to leave off the decimal point so that when you count these sig figs, you only have 1, 2 sig figs. So when you're rounding, count out how many sig figs you need. You always start from the leftmost sig fig and you count over until you get the number you need. I like to put a line over my last sig fig so I can keep track of where it's at. Then you look to the number to the right of that. If it's less than 5, you're going to leave that last sig fig as is. If it's greater than or equal to 5, you're going to round that last sig fig up 1 number. Okay, so let's do a little bit of practice with this. Let's round each of the following to 3 sig figs. We'll write out the rounded value in standard notation, and then we're going to write the answer also in scientific notation. Okay, so we want to round 109,345 to 3 sig figs. So let's count over 1, 2, 3. So the 9 is our last sig fig. I'm going to look to the right. It's a 3. So we're going to leave the 9 as is. So we get 109,000, and I fill in those spots with zeros. And then no decimal point. Because if I put a decimal point here, then these zeros would count and I'd end up with 6 sig figs. I only want 3. So I have to leave out the decimal point. Now to write this number in scientific notation, to get a little more practice with that, we take where the decimal point would be and count how many spots over we need to move. 1, 2, 3, 4, 5. So we get 1.09 times 10 to the 5th. When we write things in scientific notation, there should only be the correct number of sig figs showing, which is one of many reasons, if you can't tell, why I love scientific notation. It takes the guesswork out of like, did she leave off a decimal point because she just forgot to put it there? Did she mean to not put it there? It takes out all that guesswork because you only write the sig figs in scientific notation. If a 0 isn't significant, you don't include it in the scientific notation. Okay, let's work on the next one. 19.99, we're going to round this to 3 sig figs. So let's count over 3 spots. 1, 2, 3. So this 9 here is my last sig fig. I look to the right, it's a 9. So this gets rounded up, turns it to 10, and you have to carry the 1 over again. So we end up getting 20.0. So again, this is our number 3, third sig fig. It gets rounded up. So you turn that into a 0 and you carry the 1. But then this one gets rounded up. 9 plus 1 makes 10. Add 1 here, and that's how you get 20. So if we wanted to write this in scientific notation, take the decimal point, move it over 1 spot to the left. So we get 2.00 times 10 to the 1. Notice it still has 3 sig figs, clearly shown in scientific notation. So it takes the guesswork out of thinking like, did she mean to put that decimal point there or not? Did they leave it out? Is it meant to be or is it not meant to be? Once you put it in scientific notation, it should be very clear about what the intent was. Okay, let's do the next one. 0.01569. We want to round this to 3 sig figs. So we start counting with our first sig fig right here, the 1. These are leading zeros, so they don't count. So we have 1, 2, 3. So the 6 is our third sig fig. So we're going to look to the right. It's a 9. So the 6 is going to get rounded up to a 7. So we get 0.0157. And then if we want to write that in scientific notation, we grab the decimal point and move it over. We get 1.57 times 10 to the -2, because we had to move it 2 spots to the right. And we can clearly see that has 3 sig figs. Okay, last one. 0.009357. So let's figure out where our third sig fig would be located. We don't count the zeros because they don't count as significant. They're leading zeros. So we go 1, 2, 3. So the 5 is the last sig fig we want to keep in this value when we round it. So we're going to look to the right. It's a 7. So we're going to round that 5 up to a 6. 0.00936. And if we wanted to put that in scientific notation, move the decimal point over, you get 9.36 times 10, and we move 3 spots. So times 10 to the -3. And we can see there's 1, 2, 3 sig figs in that scientific notation. So again, scientific notation is a really great way to check that you wrote the right number of sig figs, that any leading or trailing zeros that should be not counted as significant are left off of the scientific notation. So you just have 3 digits left to show you have 3 sig figs. Okay. Next, we're going to talk about multiplication and division with sig figs. When you're doing multiplication and division with numbers that have sig figs in exact numbers, you want to count the number of significant figures in each number that you're multiplying or dividing, and then you limit the sig figs in the answer to the lowest count. So let's say we have 5.02 times 89.665 times 0.10. You put it into your calculator, and your calculator doesn't know how to count sig figs. So it's up to you as the scientist to count the sig figs and then report your final answer with the correct number of sig figs. So what you do with multiplication and division is you count the number of sig figs in each value that you're multiplying or dividing. So here we have 1, 2, 3, 3 sig figs. Here we have 1, 2, 3, 4, 5, 5 sig figs. Here we have 1, 2, 2 sig figs. Right? This is leading, so it's not a sig fig. So our value with the fewest sig figs, we had 3, 5, and 2, is 2 sig figs. So our final answer should have 2 sig figs. 1, 2. So the 5 is going to be the location of our last sig fig. We look to the right to see if we need to round it. We don't. 0 doesn't round up. So our final answer is 45, reflecting that it has 2 sig figs. So when you do multiplication or division, jot down the number of sig figs in each number that you're multiplying and dividing, and whichever number has the fewest sig figs, that's the same number of sig figs that your final answer will have. So let's do a practice one. We have 5.982 divided by 6.10. I punch this into my calculator here. 5.892 divided by 6.10. Get a whole string of numbers on my calculator. 0.96590016, and it just keeps going. We can't keep all of these digits, right? It wouldn't reflect the precision of our measurements. And so we need to count the sig figs in each of our values and then limit the final answer based on those counts. So here we have 1, 2, 3, 4 sig figs. And here we have 1, 2, 3 sig figs. This is the lowest. And so that's going to be the number of sig figs we can have in our final answer. So we can have 3 sig figs in our final answer. So 1, 2, 3. The 5 is our last sig fig. So we look to the right. It's a 9. So our final answer ends up being 0.966 with 3 sig figs. So first thing to do when you do multiplication and division, you can plug everything into your calculator, but then you always have to go back and check the sig figs. Count up how many sig figs are in each of the numbers that you're multiplying or dividing. Whichever one has the fewest number of sig figs, that's the same number of sig figs that your final answer can have. And we do a whole bunch of multiplication and division problems when we're doing unit conversions, which is coming up in chapter 2. So you're going to be using this rule all the time in this class. Okay, next is for addition and subtraction. So if you're adding or subtracting numbers that have sig figs, you have to limit your final or reported answer to the rightmost column that all numbers have significant figures in common. So what this looks like is if you're adding 5.74 plus 0.823 plus 2.651, you would line up these numbers and then draw a dotted line or cut it off at the last column that they all have sig figs in. And so in this case, the last sig fig is in the hundredths place. That they all have in common. And so your final answer has to be rounded to the hundredths place. So unlike multiplication and division, where it's just based on whatever number has the fewest sig figs, that's the sig figs in your final answer. Here it's based more on the precision of your measurements, like how far to the right of the decimal point do they go. So you line them up, and then wherever one of them stops having sig figs, that's your cutoff point. I like to count the sig figs, like locate the place, like, so I don't have to line them up. I could say hundredths, thousandths, and this one ends in the thousandths. And I'd be like, okay, hundredths place is the least to the right that's where it's going to be cut off. So I know to cut this one off in the hundreds place. So let's do an example, 4.8 minus 3.965. So this is subtraction. So your sig figs are going to be rounded or limited based on whichever answer has the least amount of precision or where the numbers line up on the rightmost column. So here this number ends in the tenths place. And here this number ends in the thousandths. Tenths is less precise. And that means that's going to limit. It's the least amount to the right. This one goes 3 digits to the right of the decimal point. This one only goes 1 digit to the right. So the final answer is going to be limited to 1 digit to the right of the decimal point. If we line it up, you'll see the same thing. 4.8 minus 3.965. And if we draw our little line to cut it off where they stop, it ends in the tenths place. So when you plug it into your calculator, calculators don't know how to handle sig figs. You have to do that after you do your calculation. So I do 4.8 minus 3.965. I get 0.835 for my final answer. It needs to be cut off here in the tenths place. That's my last sig fig. So I'm going to look to the right. It's a 3. So for my final answer, I get 0.8. And so when you're doing addition and subtraction, it's a little tricky because unlike multiplication and division, where your number of sig figs in your final answer is going to match one of your other numbers in the problem, here that's not necessarily true, right? We started out with a number that had 2 sig figs minus a number that had 4 sig figs, and we ended up with a number that only has 1 sig fig. It's not based on just the pure number of sig figs, it's based on where they're located. And so you can line them up for addition and subtraction, or if you're good with remembering like tenths, hundredths, thousandths, 10,000ths and what those mean, like how many spots over they are, you can just remind yourself like tenths place, thousandths place, hundreds place, and then recognize that the tenths place is the least to the right, and that's going to be what limits it. Okay, so if you have a multi-step calculation, like you have some steps in parentheses, like multiplication or division, and then you do some addition and subtraction, what you want to do is do the steps in parentheses first. You want to follow like PEDMAS from algebra, parentheses, exponents, multiplication, division, or addition, subtraction to do order of operations. And then as you're doing those kind of intermediate steps, you want to determine the correct number of sig figs for each intermediate answer. You need to keep track of the sig figs in the intermediate answers with a line or a mark so you don't forget where they're at. And then what you do, and this is really important, is you don't round your intermediate answers. You keep track of the sig figs, and then you keep 1 extra sig fig when you go on to the next step. This is because if you rounded each intermediate answer, like cut it off at the appropriate number of sig figs, by the time you got to your final answer, if you have like a 5-step problem, all that rounding is going to give you the wrong final answer. And so we want to keep an extra sig fig at each step until we get to the final answer. And then we just round the final answer to the appropriate number of sig figs based on if we did multiplication, division, or addition and subtraction at that final answer. So we'll do some examples. It's really important again. Follow the correct order of operations, do what's in parentheses first. Keep track of sig figs for your intermediate answers. Don't round them fully. Just keep track of where the sig figs would end if you were at the end of the problem, and hang on to 1 extra one because it gets really tedious if you're trying to write down like 20 digits from your calculator. You don't have to write down all 20. Just write down to the last sig fig and then take 1 extra number to make sure you're not going to run into this rounding problem if you start rounding things too soon. So let's illustrate what I'm talking about with some examples. And this is again just saying, because the successive rounding can compound inaccuracies, you need to round the intermediates correctly. And again, do the parentheses first. Keep track of your sig figs. but then keep one extra until you get to the final answer, and then round the very, very last answer to the correct number of sig figs. Okay, so here we have this problem, 3.5 plus 2.456 times 9.123. So this is a multi-step problem. When you solve this, you want to do the part inside the parentheses first, and you keep track of the sig figs for that operation. So we have multiplication. And so when we multiply 3.5, or sorry, we add 3.5 plus 2.456, you get 5.956 on your calculator. And we have to limit that to the tenths place because 3.5 ended in the tenths place. And when you're doing addition or subtraction, whichever one ends the least to the left, has the least precision, that's going to limit your sig figs. So we're limited to this 9 here, but we don't want to round it yet. If we rounded it to 6.0 at this point, because if you round it, right, the 5 bumps this to a 10 and turns that to a 6. If you rounded it now before doing the next step, and then you did that through multiple steps, you'd end up with a different final answer. So what you want to do is just keep track of the sig figs. Draw a line or a mark or a star, whatever you prefer, over your last sig fig that you would be rounding at if this was the last step of the problem. It's not, but we just want to kind of keep tabs on where our last sig fig is. And then you hold on to 1 to 2 extra digits so that you don't end up with a different answer at the end from premature rounding. Now I do the next step. This is my multiplication. So we take 5.956 times 9.123, and you get 54.336588. I might just go on and on your calculator, depending how big of a screen you have. This last step is a multiplication step, so it's limited by the fewest number of sig figs. So if we count sig figs in both of our numbers that we multiplied, we have 2 sig figs in 5.956. We didn't round it, but we knew that this is our last sig fig based on the addition step. And then we have 4 sig figs in the other number we're multiplying. So 2 sig figs is the fewest number of sig figs in this last step. So we're going to count over 2 sig figs, 1, 2, and round our final answer based on that. So we end up getting 54 as the final answer. So again, follow PEDMAS. You'll want to do parentheses first, then exponents, then multiplication, division, subtraction, addition, and then subtraction. So follow order of operations. And for each step that you do, keep track of the sig figs for that step. I like to underline or put an overline next to them, and then keep an extra 1 to 2 digits beyond the last sig fig so that you don't end up messing up your rounding at the very end. Then do the next step, follow the sig fig rules for that next step, keep track until you get to the very final answer. And then on the very final answer, you round your final answer based on whatever operation you did to get there, multiplication, division, addition, or subtraction on your last step. And then you finally round your last answer to that last final correct number of sig figs. So let's do this one together. We have 249.362 plus 41 divided by 63.498. So pause it if you need to, work it out on your own, see what you get, and then I'll go through it with you. Okay, so to start this one out, we want to do the operation in parentheses first. So when I add those two up, let me grab my calculator. 249.362 plus 41. And I get 290.362. But then this is addition, so we've got to cut it off here in the ones place because that's where 41 ends at. The ones place. So this 0 and 290 is our last sig fig. If this was the whole problem, we would round it to 290. But it's not, it's just the first step in a multi-step problem. So what we're going to do is we're going to have 290.4. I'll keep one extra digit. And I'm going to keep track of where my last sig fig is based on that step I just did. It ends in the ones place because 41 ended in the ones place. We had to cut it off at 41 when we lined it up. And then I'll do my last step. 290.4 divided by 63.498. 290.4 divided by 63.498. I get 4.57337, and it just goes on and on my calculator. So now we have to round this final answer to the right number of sig figs based on our final operation. So here I have 3 sig figs, and here I have 1, 2, 3, 4, 5. And so this last step is division. So my final answer needs to be rounded to the number with the fewest sig figs. So it's going to also have 3 sig figs. So when we round it to 3 sig figs, we get 4.57. So again, multi-step calculations with sig figs. Do the steps following the order of operations. For each step that you do, keep track of the sig figs for that step. But then when you go on to the next step, don't round it to that number of sig figs quite yet. Keep one extra number. And then when you get to your final answer you round to the correct number of sig figs based on whatever operation you did before your final answer. So here I divided before my final answer. So I follow the division sig fig rules, which says whichever number has the fewest sig figs, that same number of sig figs I'll have in my answer. So this number had 3 sig figs, 290. So my final answer also has to have 3 sig figs. Okay, so check out the homework, start doing the chapter 2 homework. You're going to get practice with doing this type of stuff. All of the odd numbered questions, the answers are in the back of the book, the next page over on the online textbook. So you can check your work as you go. This is a really important concept, and we're going to be, for all future calculations in this class, following these rules for sig figs and rounding. Okay, so next lectures are going to be on units of measurement and unit conversions. I'll see you then. Thanks, everybody.